Hi, good morning. I am Akhil, Assistant Professor, Department of Mechanical Engineering, Vedivasa Institute of Technology. I am here to deliver a talk on airplane aerodynamics. We are going to start with the basic question, how an airplane fly, which is a very critical question. I think everybody should know the answer to this. So we are going to cover how an airplane fly in this talk. Let us look into the major airplane parts. First one is engine and propeller, which is at the front of the airplane. Then fuselage, the whole middle parts where the passenger sits is the fuselage. At tail, there is a vertical part which can tilt side to side called a rudder, and there is a flat horizontal part that is actually can go up and down, which is called elevator. Then we have wings. Sometimes it has struts to support the wings. Then there is a landing gear, including wheels at the bottom. The other things we need to talk about are the main four forces that are on an airplane. The force going up is lift, and that force opposes the downward force of weight. Then when we are moving the airplane forward, that's thrust, and it is opposed by drag. So in order to the airplane to go up, the lift has to exceed the weight, and in order to the airplane to go forward, the thrust has to exceed the drag. Those are the main four forces on an airplane. Now let us learn about Bernoulli's principle. Daniel Bernoulli, a Swiss mathematician, expanded on Newton's ideas and discovered the motion of fluid. He described in his publication Hydrodynamica the basic principles of airflow pressure differential. The principle simply states that as the velocity of a fluid increases, its pressure decreases. Let's look at the diagram to understand this concept a little better. As the air or fluid in general travels through the tighter passage of the tube, the velocity increases, since fluids travel at a faster speed to reach the end of the curve. What's interesting is that when he measured the pressure, Bernoulli discovered that every time the velocity increased or decreased, the pressure would have the opposite effect. As you can see, an airfoil, which is the shape of the cross-section of wings of an airplane, the fluid, that is airflow, on the upper side will be at a high velocity, and at the lower side the airflow will be at a lower speed. This will create a high pressure at lower side and low pressure at the upper side, which gives the lift to the airplane. Here we will define a very important force, that is relative wind. The relative wind is simply the airflow that is parallel and opposite to the flight path of the airplane. An airfoil is any surface, such as wing, that provides aerodynamic force when it interacts with a moving stream of air. When given a flight path and an opposite relative wind, it's important to remember that the airflow over the surface of the wing will have a higher velocity than the airflow under the wing. It is also important that the circulation on the airstream above the airflow is an important factor in the generation of lift. Next, we will look into some important terms. The camber. It is the characteristic curve of the airfoil's upper and lower surfaces. The chord line is an imaginary straight line that joining the leading and trailing edge of an airfoil. The chord line is a very important determinant of what we call the angle of attack. The angle of attack is the angle between the chord line of the airfoil and the direction of relative wind. As the angle of attack increases, the lift also increases. The lift acts perpendicular to the relative wind regardless of the angle of attack. According to Bernoulli's principle, the increased speed of the air on the top of an airfoil produces a pressure drop. This lowered pressure is one component of the total lift. However, when the angle of attack is increased beyond the maximum allowed, the lift is decreased. This causes what we call a stall. As we mentioned earlier, a stall is the result of a critical angle of attack. It is also caused by the disruption on the airflow from the upper surface of the wing or airfoil. The airflow then separates at the trailing edge. The airflow progresses forward until the wing is fully stalled. Therefore, a stall is a rapid decrease of lift caused by separation of airflow. In order for any wing to generate lift, it has to be in a fluid. If this airplane was in space or in vacuum and there wasn't any fluid passing by it, then you couldn't push the wing up. But the fluid doesn't always have to be air. You might see similar designs underwater. It just has to be a fluid that's passing by the object. So when you have this airfoil in a fluid, when the fluid is not moving, when it's stationary, then all of the fluid is exerting pressure on the airfoil. When the fluid is not moving and the airfoil is stationary in the fluid, all those forces perpendicular sum to zero. But when the fluid is moving, it generates a force. The force has a vertical and a horizontal component. We call the vertical component the lift and horizontal component as drag. A lot of people might be under the misimpression that it's only the wings that are generating the lift. Well, actually, the whole aircraft is generating lift, and it's not just aircraft. Any object that are moving through fluid can generate lift. I hope you got a basic idea of airplane aerodynamics. Thank you.